Hi, in this part we'll be studying maxima and minima. Now what is maxima and minima? Now basically, let's say you have a small thing, okay, what is if you want to fit it somewhere, okay, let's say you have a ball, if you want to fit it somewhere, but you either find the hole to be very small or the hole to be very big. So what is the minimum size of the ball that should be required or the maximum size of that ball to be required? The main point of studying maxima and minima is that only. We will be studying maxima and minima including different theorems. Okay, there are 3 basic theorems that you will be going through in this chapter, and here we will first introduce to you the second derivative part. Basically when we study second derivative, what we do is after differentiation of a function, we differentiate that function again. Okay, let's look ahead in this topic. You will come to know about it and learn about it. Okay, now coming to maxima and minima. Now, in this section, before let's getting into the technical parts, let's just look at what we have over here. Take a standard sheet of paper, 8 inches by 11 inches. Okay, now cut it into strips high, and strips high means maximum number of strips that you can get. Okay, that is one either vertically or horizontally. Okay, now in this case, if you have a look, you can have two different kinds of strips. One which will be along the vertical, and that will give you a different number of strips. Okay, and one would be along the horizontal. Okay, and that will give you the lesser number. Okay, let's say you try both the ways, and in one you get 64 and in the other you get 88 strips. Okay, now the main motive over here is to know what is the maximum that you can do. Okay, and by maximum, when we come to this part, it is a little difficult to understand. Okay, let's assume, okay, you have 64 strips in one side and you have 88 strips in the other side. Okay, if you use those strips to cover particular ground or particular area, you will have different areas. Okay, in one area you will have, let's say, some x meter square. Okay, and in the other case you have y meter square. Okay, now look at the 2 questions that we have jotted down here. How would you cut the sheet? Okay, but before you understand that, you need to know in which case you cover the maximum number of area. Now you can use your best imagination. Okay, now this is just for the imagination, but you don't have to calculate or anything. To this part, you just have to use your imagination to cover maximum area using the strip. Okay, now after doing it, after putting in a lot of effort, you will come to a part where you actually have finished it. Okay, so 64 strips will cover a maximum area of this, and 88 strips will cover the maximum area of this. Okay, now in either of the cases, after completing, you'll get the areas, let's say x and y that I mentioned. After doing that, you are struck with the thought that if I would have cut the strips in a different way, I would have probably gotten more area, I would have covered more area, right? It may so happen. Okay, in that case you come to know what is the maximum that you can do, or what are the conditions to get a maximum value or a maximum area or a maximum result. Okay, now then you will come using which condition, how much ground can you surround. Alright, figuring that out is the first part, and then taking out the maximum area is the next part. Alright, now let's look at some of the trivias. Okay, you remember both the picks. Okay, I have taken, these are the live examples from cricket. Okay, and I hope some of you are cricket fans. Okay, now if you have a look, then you will come to know that in both the cases, these are the maximum that could happen in an over. Alright, let's say this is Yuvraj Singh's inning, okay, against England in the first ever T20, right? I'm sure everyone remembers this one. Okay, now in this case, what did Yuvraj Singh do? He scored a maximum number of runs that was possible, right? That is obviously considering legal deliveries. Alright, same is the case of Herschel Gibbs over here, right? You may or may not be remembering this, but this is from World Cup 2003, alright, where Gibbs hit 36 runs again, okay? This was World Cup 2003. Now in both the cases, it is common term that maximum runs per over was scored, right? 36 in both the cases in 6 balls, right? So this is the best a batsman can do in 1 over, right? The maximum that one can do, right? Now if you take a bowler, okay, now this has not happened, but the best a bowler can do is take 6 wickets in an over, right? Lasith Malinga, you might be knowing, has come closest of taking 4 wickets in an over. But in that case, you see, the variable changes. There are 2 ways in which an over can be best. One, by giving no runs at all. Another, taking maximum number of wickets during that over. Now, if you take 6 wickets in an over, automatically it will result in 0 runs. Also, you can take 0 runs and as many wickets as possible. So there are 2 variables in that case where you can satisfy, you can put it up in the best category. Okay, but obviously the best would be if you take 6 wickets in an over, which is rather difficult than hitting 6 sixes. Okay, so that is the way of understanding what a maximum a bowler can do, what a maximum a batsman can do. Now the worst case that a batsman does, what could that be? Giving away a maiden over, right? Similarly, the worst a bowler can do is giving away 36 runs, as was the case in both these cases. Alright, so this is what understanding is maxima and minima. Now, in the previous part, we did have a little bit of that understanding, right? Understanding monotonicity. In that we did understand about local maxima and local minima. But this case, it is going to be in the complete spectrum also, as well as in the local spectrum also. Moving forward, what does the definition of maxima and minima say?